All right, guys. Today we're going to be going over some radical stuff. Most of this stuff you will have learned in Algebra 1, but it's better to not assume that we remember things and good to go over stuff. So a radical, right, is just the name for a square root, okay? Like the square root of 4 is 2. So this like shape, we call that a radical. And before we can start working with radicals, one thing that it's important to talk about are the perfect squares, okay? You need to know the perfect squares. They're really things that you should have memorized. So the perfect squares are any number that you could get by squaring a whole number, okay? So 1 is a perfect square because it's 1 squared, right? 2 squared is 4. So 4 is a perfect square. 3 squared is 9. So 9 is a perfect square. And you can keep going on in this way. So, 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100, 11 squared is 121, and 12 squared is 144. And so these are the first 12 perfect squares. Normally, you're not going to go past this. 144 is already a pretty big number, but you should probably know these numbers. You should have them memorized, and if not, you should have them written down somewhere that you can access quickly. The reason for that is because we are going to simplify radicals, okay? And in order to simplify radicals, you need to be able to break up a number into 2 factors, right? So we want to break up 18. Now, when you break up 18, you have 2 choices, okay? You can do 9 times 2, or you can do 6 times 3. And notice that when I'm writing down its 2 factors, I'm putting them both inside a radical as well because that is the square root of 18. The reason you have to do this is because 18 is not a perfect square. So if we tried to take its square root, you would get some kind of crazy decimal, right? So we want to break it up. Now, if I'm looking at all 4 of these numbers, right? The square root of 9 is 3, okay? The square root of 2, crazy decimal. The square root of 6, crazy decimal. The square root of 3, crazy decimal. So the only one of these numbers that we can take the square root of is 9. So we do not want to break up 18 into 6 and 3. That would be bad because we took a crazy decimal and just made 2 crazy decimals, okay? We want to break it up into 9 times 2. So you want to break up your number using a perfect square. That is why it is important that you have access to this list. You need to figure out which number on this list divides into the number that you are dealing with, okay? So the other number, the number that is not a perfect square, which in this case is the square root of 2, okay? That number just stays as is, okay? We can't do anything with it. So we just leave it there. So the square root of 9 is 3. The square root of 2 stays the square root of 2, okay? And that is how you simplify radicals. This is something that we're going to be doing a lot in this unit, and it's something that you need to be able to do. So real quick, this example here, the square root of 72, okay? Here, you have a couple choices, but the best choice is the square root of 36 times 2. If you have multiple perfect squares that can go into a number, like for example, 4 can go into 72 and 9 can go into 72, it's 9 times 8. And 72 is 4 times 18. Okay, so there's really 3 perfect squares that go into 72. If you have a choice, you want to do the biggest one. Okay, so we want to do 36 because the square root of 36 is 6, and we get 6 radical 2, which is the best way to do this. You guys can try that one on your own. Okay, this one, sometimes you have a number outside, that's fine, okay? You're just gonna leave it outside, okay? We just have a 5 out there. We're gonna ignore that for now. The square root of 45, that is 9 times 5, okay? The square root of 9 is 3, so this becomes 3 radical 5, and now we see, okay, we also have a 5 out in front, so we can multiply 5 times 3, and that makes 15, so we have 15 radical 5, and that is our final answer. So if you have a number out in front, just kind of leave it out in front and deal with it at the end, okay? Now, another thing that we're going to do is multiplying radicals, okay? When you're multiplying radicals, it's kind of the opposite of what we were doing when we were breaking it up. You just multiply the two numbers in the radical, okay? So radical 5 times radical 10 is radical 50. Now, what you want to do here is you want to look to see, can 50 be simplified? Are there any perfect squares that goes into it? The answer is yes. Okay, 50 is 25 times 2. The square root of 25 is 5. So our final answer is 5 radical 2. Okay. Now, if you have numbers outside the radical, again, you just leave them outside and you multiply the numbers that are inside, okay? So 3 just kind of stays outside. On the inside of the radical, we want to do 12 times 6. 12 times 6 is 72. And we know 72 can be simplified because we already did it up here. It's 6 radical 2, okay? So we have 3 times 6 radical 2. And again, whenever you have multiple whole numbers that get brought outside the radical, you can multiply those together. So this one will be 18 radical 2. All right. If you have multiple numbers that are outside, you just multiply them. Okay. It's nothing crazy. We have 6 and a 3 outside, so 6 times 3 is 18. Inside the radical, we have 3 times 21, that's 63. Can 63 be broken up? It can. It can be broken up into 9 times 7. So that is 3 radical 7. We have the 18 out in front. So then we want to do 18 times 3, which is 54. So our final answer would be 54 radical 7. And again, this is kind of the process that you want to go through, okay? Now, the last thing that we're going to be doing is dividing, or you can think of it as just like having a fraction. We call this rationalizing the denominator because you do not want the denominator to be a square root, basically. There are a lot of reasons for that, but mostly they have to do with higher math, but we just need to practice it pretty much. So if you have a square root in the bottom of your fraction, you are going to follow this process that I'm going to explain right now, okay? It might seem arbitrary, but you just need to know it, and this is what you have to do, okay? You want to multiply by whatever is in the square root on the bottom over itself. Okay, the reason you're allowed to do this is because anything over itself is equal to 1. So really we're not changing our number, we're just multiplying it by 1. All we're doing is changing its form, okay? So when we multiply straight across, okay? So 4 times radical 5 is just 4 radical 5 because the 4 is not in a radical, the 5 is in a radical, so we don't multiply them together, okay? The radical is like a force field. The 4 stays on the outside, 5 stays on the inside. However, on the bottom, they're both inside the radical, so we can multiply them, and 5 times 5 is 25, and 25 is a perfect square. The square root of 25 is 5, okay? So this is why we want to multiply the same number by itself, because we're guaranteed to get a perfect square, and your answer here would be 4 radical 5 over 5, and believe it or not, that is actually a better form than the first form, because now the radical 5 is on top. This can look a couple different ways, so let's just do another one. Remember, you only want to multiply by the number that is in the bottom of the fraction. We don't really care about anything on top because we know a radical is going to end up on top. We just want to get rid of the radical in the bottom. So here we only want to multiply by the square root of 3 over the square root of 3. On top now, since both numbers are in a radical, we can multiply them together and we get the square root of 15. On the bottom, square root of 3 times square root of 3 is square root of 9, and that is a perfect square, so we can take the square root of 9 and we get the square root of 15 over 3, which is our final answer. Last one that we're going to do together, here we have 2 radical 3 in the bottom. Same as before, but we only care about what is in the square root in the bottom. We don't need to multiply by 2 radical 3 over 2 radical 3, although you could do that. It'll just going to make your numbers bigger. So on top, square root of 2 times the square root of 3 is the square root of 6. On the bottom, the 2 just stays on the outside. Square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is a perfect square. So we can take its square root, it's 3. So now on the bottom we have 2 times 3, which is 6. So our final answer is the square root of 6 over 6, okay? So that is everything basically that is on your worksheet. So if you need to rewatch this, you can, or I think I'm probably gonna put other YouTube videos in this assignment too if you wanna watch someone else explain it. But this is what you need to know how to do for the rest of the stuff coming up this week.